In this video, I'll discuss the color of shadows and the color of light, and whether it's caused by the color of the sun or the sky. And it's in my book, the Art Instruction Course, Color and Light, which is only $7. There are two main light sources outside. There's the sunlight, which is direct light, and it's very intense and focused and gives us bright highlights and sharp, dark shadows. And then there is skylight, which is diffuse light. And because our atmosphere is full of air, it scatters light everywhere. And if we didn't have that blue skylight, well, the sky would be black like it is on the moon. Because our sky is usually blue, it casts a soft, weak blue shadow, or blue glow on everything. Now, when sunlight hits an area, it's so strong that it eliminates that blue from the sky. So the only place that we can see the blue from the sky are areas that are not hit by the sun, like shadows and shaded areas. And I'm going to show you examples of this in the next few minutes. Objects on land don't have a permanent color. Rather, they reflect the sky above them. So when the sky is blue, the water looks blue, but so does the terrace and the railings. When the sky is orange, then everything turns orange. The blue sky gives everything a blue tint, but the sunlight is so bright that it washes out the blue tint from the sky, which is why a white shirt looks white when it's in the sun. But the sun can't reach shadows, so white surfaces in particular, like snow, a tablecloth, or ice, have a bluish tint. This snow is blue because it's on an overcast day, so the sun is behind the clouds. This tablecloth is in a shaded area, so it doesn't receive sunlight. And this ice is blue because it's shielded from the sun. And you can see that the sun is near the horizon. It has some orange, so it's turning these trees and buildings orange, but the ice is shielded from the sun, so it has some blue. To find the position of the sun, draw a line from the shadow to the spout that's causing that shadow, and then go upward, and that will be where the sun is located, in the upper left. Now notice this shadow has a blue-gray color, and if you cast shadows on a variety of colors, I've picked out the colors from the shadows over here. So this would be this red color in shadow, and this is yellow in shadow. Always ask yourself, is a shadow a blue-gray, a violet-gray, or a green-gray? Try to see colors in gray, and then your paintings will look much more alive. The color of the sun depends on how much atmosphere it passes through. At noontime, the sun travels through the least amount of atmosphere, so it becomes yellow or white. Since the light area of an object reflects the color of the sun, a light area at noon should have some yellow in it. At sunset, the light goes through much more atmosphere, so it loses blue rays, and as a result, the sun looks orange or even red. So the light area at sunset should have some orange in it. Shadows require an opaque, non-shiny surface to become visible to the viewer. In this first case, the shadow is falling on the silt on top of the water, and in this case, it's falling on the sand. And since shadows are transparent, you can see the ground underneath them. And because they represent the lack of direct light, they are always positioned opposite the light source. So here the sun is here, it hits the object, and the shadow is down here. Furthermore, shadows reveal the colors of the casting surface and the color of the sky, but not the color of the object. And they shift with the position of the light source. In contrast, reflections appear vertically below the object, and they match the object's length and width. And they shift according to the position of the object and the viewer. So each viewer sees a different reflection. Now, because they're on the surface, they hide what's underneath. And reflections depend mainly on the color of light and the color of the object. So these reflections are yellow, indicating that the sun must have some yellow in it. This table summarizes the differences between shadows and reflections. Shadows are caused by a block of direct light, so it occurs opposite the light source, and it varies with the position and angle of the source, as well as the viewer's perspective and the shape of the ground. Whereas reflections are due to bouncing light rays, so if the surface is horizontal, the reflection is underneath the object. So it varies with the position of the viewer and the object, as well as whether the surface is rough or smooth. Surfaces preferred, shadows like matte or opaque surfaces, reflections like shiny surfaces. Shadows, the surface underneath is visible, but it's darkened with less detail evident, whereas reflections do obscure the surface. Values for shadows are darkest near the casting object if we exclude the effect of reflected light, and reflections mirror the values of the object. For colors, shadows show the ambient light, usually the sky, as well as the colors of the surface, whereas reflections are mainly due to the colors of the light and the object. As far as size, shadows are dictated by the size of the object, the light angle, and perspective, whereas reflections typically match the proportions of the object. I'll leave a link to my book, Color and Light, at the bottom of this video, and please remember to subscribe.